Welcome everyone. I'm excited to kick off our presentation today. We'll be exploring the fascinating world of machine learning, starting with a focus on underfitting. We'll look at what underfitting means, why it's important, and how it impacts our models. Over the next few slides, we'll dive deeper into these concepts and learn how to address them. Let's get started. All right, let's talk about underfitting. It happens when our machine learning model is too simple to really grasp the true underlying structure of the data. Think of it as trying to describe a complex map with just a single straight line. It's just not enough to capture all the details. When a model underfits, it doesn't perform well on the training data itself, which is a big red flag. And it gets worse because it also performs poorly on new, unseen data, meaning it hasn't learned enough to make accurate predictions. So, in a way, underfitting shows us that our model is too basic, and we need to make it more sophisticated to better understand the data's complexity. This is a key concept because it highlights the importance of finding the right balance in our models, neither too simple nor too complex. Let's talk about the straight line trap. Imagine your data actually follows a curve, like a parabola. If you try to fit a linear regression model to that data, it just won't capture the true pattern. The model will never really fit those points correctly because it's too simple to match a curved relationship. One key indicator of this problem is a high training error. If your model can't even learn the data you're giving it right now, it's a sign that it's underfitting. And that's usually caused by high bias, meaning the model is too simple to capture the underlying complexity. So, in essence, when we see high bias, we're dealing with underfitting, which prevents our model from making accurate predictions. All right, let's take a closer look at some of the root causes behind model issues. First up, model simplicity. Sometimes we choose a linear model for data that's actually nonlinear, and that just doesn't capture the complexity we need. It's like trying to fit a curve with a straight line. It simply won't do the job well. Next, insufficient features. If we don't provide enough relevant input variables, the model doesn't have enough clues to learn from, which hampers its performance. Think of it as trying to solve a puzzle with missing pieces. Then, we have excessive regularization. While regularization is meant to prevent overfitting, if we're too strict with it, the model can become too constrained and fail to learn important patterns. It's a balancing act. Lastly, lack of training time. If we stop training too early, the model might not have fully learned what it needs to, kind of like stopping a race before the finish line. All these factors can significantly impact our model's success, and understanding them helps us troubleshoot more effectively. All right, so to really address underfitting, we can start by increasing the complexity of our model. That might mean switching from a simple linear regression to something more powerful, like a polynomial regression or even a deep neural network. The idea here is to give our model more capacity to capture the underlying patterns in the data. Next, feature engineering is crucial. By adding more relevant input variables or combining existing ones, we give the model more context. This helps it understand the data better and can significantly improve performance. Another key point is reducing regularization. If we've been applying constraints like L1 or L2 penalties, dialing those back can give the model more freedom to fit the data. Sometimes, too much regularization can prevent the model from capturing the true patterns. And finally, training longer is often overlooked, but very important. We want to make sure that the error or loss has actually plateaued before we stop training. If we stop too early, the model might still have room to improve and better fit the data. Altogether, these steps form a comprehensive approach to curing underfitting and making our models more accurate and reliable. Thank you for watching. Like, share, subscribe to EC Learning 360 YouTube channel.